IPv6, or IPv6 for short, is a new version of the Internet Protocol designed to replace IPv4, the Internet Protocol that is predominantly deployed and extensively used throughout the world. Although the exhaustion of available IPv4 address space has been the primary reason for the development of a new protocol, the designers of IPv6 have added many new features and a number of critical improvements to IPv4. IPv4 has stood the test of scaling an internet work to a global utility the size of the internet today, but IPv4 wasn't initially designed to support a high number of network equipment. Because of the recent exponential growth of the internet, IPv4 is unable to satisfy the potential huge increase in the number of users or the geographical needs of the internet expansion. As a result, IPv4 address depletion is approaching quickly. Additionally, emerging applications such as Internet-enabled PDAs, home area networks, mobile ad hoc networks, IP wireless services, and integrated IP telephony services require a new Internet protocol. The lifetime of IPv4 has been extended using techniques such as address reuse, with Network Address Translation, or NAT for short, classless interdomain routing, or CIDR, and temporary address assignments such as the Dynamic Host Configuration Protocol, or DHCP. These techniques appear to increase the address space and satisfy the traditional server-client setup, but they fail to meet the requirements of true network and user mobility. Applications need an increasing amount of bandwidth, while address translation has a performance impact on the network equipment. Next, the need for always-on environments to be contactable prohibits these IP address conversion, pooling, and temporary allocation techniques. Furthermore, the plug-and-play feature required by consumer internet appliances further increases the protocol requirements. Millions of new technology devices such as wireless phones, PDAs, cars and home appliances will not be able to get global IPv4 addresses any longer. IPv4 will soon reach the stage where a choice has to be made between either new capabilities or a larger network, but not both. In other words, we need a new version of the IP protocol to provide new and enhanced features in addition to solving the IP address exhaustion problem. That new version of IP is IPv6. IPv6 is designed to meet the requirements of the potentially huge internet expansion. It will allow a return to a global environment where the addressing rules of the network are transparent to the applications again. Through auto-configuration and plug-and-play support, network devices will be able to connect to the network without manual configuration and without any bootstrap services such as DHCP servers. IPv6 succeeds in doing this by providing the following benefits to network and IT professionals. First, IPv6 has a larger address space for global reachability and scalability. This will result in an almost unlimited number of IP addresses and a hierarchical network architecture for routing efficiency. This eliminates the problems associated with NAT. The ability to provide global addresses for each network device enables end-to-end reachability, and network management will be simpler and easier. Second, a simplified header format for efficient packet handling. 6 of the 12 IPv4 header fields have been removed in IPv6. Some IPv4 fields have been carried over with modified names, and some new fields have been added to improve efficiency and introduce new features. Third, a hierarchical network architecture for routing efficiency that follows some of the IPv4 CIDR principles. Another important IPv6 benefit is the embedded security with mandatory IPsec implementation. While the use of IPsec is optional in IPv4, IPsec is mandatory in IPv6. IPsec is part of the IPv6 protocol suite. Therefore, network implementers could enable IPsec in every IPv6 node, potentially making the networks more secure. Additionally, IPv6 offers an increased number of multicast addresses. IPv6 will not use broadcasts, leading to a more performant network. Moreover, in IPv6, the ICMP protocol has been revised. ICMP version 6 has become much more powerful and includes new functions to support auto-configuration, neighbor discovery, and multicasting. And finally, IPv6 offers built-in mobility, as the anticipated large rollout of wireless data services is a key IPv6 driver.